let's talk about how we measure angles. So here we have an angle, which is basically kind of the space created when two lines meet at what we call the vertex of the angle. And so it doesn't matter if I was to draw these lines as I did here, where they go off the page, or if I was to draw them short, it's all the same angle. And it's just basically saying, you know, how wide open is this sort of gap where these two lines meet. So you may be familiar with probably one unit of measure in angles, and that is the degree measure. And the degree measure is based on the idea that a full turn is 360 degrees. And so 1 degree is 1/360th of a full turn. I'm not sure, but I think that might be approximately 1 degree. You may or may not know this, but all units of measure that we use as humans are chosen. They are not given to us innately in nature. They are all a choice that humans make. And so it might be an interesting exercise to ask yourself, why did we choose angle measure to be based on this notion of 360 degrees is a full turn? It's a kind of maybe a surprising number. That might be a thing that you look up. Another measure that is used less commonly, and I'm not sure exactly where it is used, but I'm sure that Wikipedia could tell you, is the gradient. The gradient is based on the idea that a right angle, which looks like this approximately, a right angle is supposed to be 100 gradients. And I think the idea of that is just that we like our measurements in hundreds or in powers of 10. So if a right angle is 100 gradients, then that means a full turn would be 400 gradients. Now, the unit of measure that we use most often in math and sciences is the radian measure. And so for radian measure, hopefully you hear the word radius in there. I'm going to build a circle that is centered at the vertex of our angle. And we're going to talk about the arc subtended by this angle and ask ourselves how many radius lengths are covered in that arc subtended by this circle. Let me just put that up. This is the arc subtended by the angle that I'm calling alpha. I have never used or heard this word subtended used anywhere other than in a sentence like the arc subtended by this angle. So that's what I mean by it if you ever see that word. Let me turn that off. And so the idea is, how many radius lengths are there that go around this arc? And so the radius length is given as a straight length, but if I kind of lay it flat and imagine how many radius lengths, I'm going to guess maybe it's about 2. And so I actually built this so that you can see individual radius lengths. So here is highlighted like 1 radius length and 2 radius lengths, and it looks like, I don't know, maybe another 1/5 of a radius length. So maybe we'll call this about 2.2 radians, this measure alpha. So let me actually see. Yep, it's very close, about 2.2 radians. Okay, so 1 radian, this is an angle of about 1 radian. And then here is an angle of about 2 radians. And you might ask yourself, how many radius lengths along the circle does it take to go all the way around a circle? And this might be a good time for you to pause the video and see if you know the answer to that question. So how many radius lengths does it take to go all the way around a circle? Okay, hopefully you paused and thought about this, and you might remember from some past math class that it takes 2 pi radius lengths to go around a circle. In fact, pi is defined to be the number of diameter lengths that go around a circle. So a diameter is the distance all the way across, so it would be 2 radii. And it takes a little more than 3, so 2 radians, or 2 radius lengths would be 1 diameter. So there's 1 diameter here, and then another diameter here, and then another 2 radius lengths. Boop. Boop. That would be 3 diameter lengths to go around the circle, and then it's about 3.14 diameter lengths that go around the circle, which means, so that's the definition of pi, actually, is how many diameters does it take to go around a circle. And so since it takes pi diameters, it's going to take 2 pi radians, or approximately 6.28 radians for a full turn. So it is important to note that this definition is not dependent on the size of the circle that I set out. So this is approximately 2 radians right here. And if I shrink the size of the circle or grow the size of the circle, the radius length and the arc subtended by the angle are going to grow proportionally. So that angle is always, that is a consistent angle measurement. Let's see. The other couple things, when we are measuring radians, or when we're measuring angles, we actually sometimes want to talk about a direction of turn. So here I have this angle has a direction to it, where it is starting on this horizontal line and then turning in the counterclockwise direction. And that is how we measure a positive angle. And if we go in the clockwise direction, we will call this a negative angle. And so it is still the case where we have the absolute value of the angle is still dependent on the number of radius lengths in the arc subtended by the angle on a given circle. But we just basically say, if you are turning in the clockwise direction, that's a negative angle. And if you're turning in the counterclockwise direction, that's a positive angle. So a couple of things. It is important to note that pi is a straight angle or a half turn. Okay. And so when you're talking about different fractions of pi, that is a place to anchor on, is that pi is a half turn or a straight angle. And then a full turn is 2 pi, and you can go more than a full turn. So here's 2.5 pi. So a right angle would be half pi, or pi over 2. So this would be 2.5 pi. Here would be 3 pi. And if I go all the way around twice, so this is looping around twice, this would be an angle of 4 pi.